Hi statistics students, I wanted to show you how to use a StatKey for a chi-square test of independence, or if you want to call it a chi-square test of association. Alright, I've pulled up here a list of government votes. I picked the House of Representatives because I have at least 5 categories in each section here, and we need to have at least 5. If I went to, let's say, Congress, voting record, slow. This one's the Senate. Right. No, I don't need to follow you. Okay. Right here, these categories of independence or not voting, I'd have to leave off because they're not 5. I'd only have 1 degree of freedom. So that's why I went to this one where it had the House of Representative votes. So even though they don't have any independents listed, in this case they have 2 degrees of freedom. And the test of association would be to see if the people who said yes are, associated with Republican or with Democrat. The people who said no, are they associated with Republican or Democrat? And not voting, are they associated? Or are they independent of each other? Okay, let me go to StatKey now. So here we have StatKey, and down here we have the chi-square test for association. And as I pull this up, I'm going to need to edit the data. You notice it says blank, and then it has first category, second category, third category, fourth. This is what they already have in here. And then categories. So let me go ahead and type this in, just so I'm not flipping back and forth between screens, and you'll see how it works. Okay, we need to leave this blank space in here because it's going to kind of cover the column right here on the left. So blank, Republican, Democrat, yes, 222, 138, no. And you notice how I have commas in between all these spaces right here. This is not raw data, but it does have a header. Let me just go back to the votes right here so we can check. So let's see, I think I've got it. So this is where we put blank right here. So it's blank, Republican, Democrat, then yes, number, no, number, and they said not voting. I said abstain. Okay, so I'm going to go back to StatKey. And now that it's got the data, I say okay. And right here, I should have the same table that I had. And notice it totaled it up for me right here on the bottom and top. And it tells me my sample size and my chi-square statistic, which is really quite large. For how many degrees of freedom? Well, 2 minus 1 is 1. 3 minus 1 is 2. So 1 times 2, 2 degrees of freedom. And as I generate, say, 1,000 samples, you can see that it really does resemble a chi-square distribution with 2 degrees of freedom. And so to get this number right here, I say a right tail and put in the number I've got, which was 24.296, and say okay, and the probability right here is 0. To have the null hypothesis of no association, I think we can definitely say that null hypothesis is, we're going to reject that null hypothesis and say that this bill right here is definitely has association with Republicans and Democrats. So even though these numbers are a little bit hard to see with the numbers this way, the chi-square test lets us see that our result is quite extreme, and there is an association. Okay, I've pulled up another vote record from the House, Tsunami Warning Education Research, and it looks like it's a lot more balanced. I look at that 8 and 8 right here. So I'm going to go back to StatKey and edit the data. Okay, let me just double check. So I've got Republican, Democrat, yes, 218, 174, no, 26, abstain, 8 and 8. Let me just check. Okay, I'm thinking the numbers are right. So let me go ahead and do the chi-square test. Okay. So yeah, look at this chi-square value. It's only 4. So, and I can see the effect that each one has. The Democrat was a little bit off from what we expect, so that's the biggest one right there. But I think overall we will not reject the null hypothesis. Let me just generate 1,000 samples. So putting in 4.812, right tail. 4.812 for my cutoff value. And right here I've got a p-value of 8%. So given our usual 5%, I would not do a reject the null hypothesis. I'd go ahead and say, yeah, I think this voting right here was pretty evenly spread out. There was no leaning Republican, leaning Democrat. I think we're pretty good there. Okay, the last example I'm getting from WileyPLUS. I went to the dataset index. I don't know why it's doing this, but I pulled up the restaurant tips. Now in this case, I'm going to be using the raw data. And let's say I want to see if credit card depends on number of guests or days of the week or server and percent tip, bill. I can find a lot of associations, maybe, with this. So just looking at it, let's see what I can come up with. Okay, I played around a bit, and I found out that I have to save it as a CVS file. Otherwise, StatKey doesn't like it. So I've saved it, and then I can upload a file and just tell it restaurant tips, the CSV file. And then here it is, and it says go ahead and select 2 categories that you want. So, does the number of guests have anything to do with the day of the week? Let me find out. So we go through, and we've got Friday, Thursday, Wednesday, Tuesday, Monday, 2, 3, 1, 5, 4, 6, 7. Okay, very interesting. I notice a lot of zeros here, but when I pull up the table, it looks like they do take it into account. So this will be a very interesting chi-square. Let's see where it's centered. Let's get 1,000 sample or 100,000. Okay, it looks like it's getting centered close to 20. So they went with 1, 2, 3, 4, 5, 6, 7. So 7 minus 1 is 6. 2, 3, 4, 5. 5 minus 1 is 4. So 6 times 4 is 24. They went with a 24 degrees of freedom. Notice where the mean is? Okay, so the chi-square statistic we have here is 38.67. Right tail. 637. Okay, and we get a p-value that's pretty small. 0.3. I'd probably reject the null hypothesis of no association. And looking at the details, looks like the biggest influence right here is 5 and Thursday. Okay, they were really not expecting 5 people to come in on a Thursday. So this one looks like it's got the biggest influence here. If I wanted to change my columns here, so did the server have anything to do with the credit card? So let's see if that had anything to do with it. So in this case we had 3 servers and yes and no with the credit card, so we're only down to 2. And so I do 1,000 samples. You notice the mean's close to 2. 2 degrees of freedom. 5.818 for a cutoff point. I would fail to reject the null hypothesis. I don't think server and credit card are associated with each other. I think that's, yeah, I don't have enough evidence. So let's just do one more. Does the server have anything to do with the days of the week? Let's see. It looks like the only person who is working on Monday is B, so I'm expecting that, yeah, we've got some big things going on here on Monday. Look at that. A lot more than we'd expect. So, and then, yep, Monday is huge. Tuesday is huge. So it looks like servers are really have a big association with the day of the week. And let's just get 1,000 samples. So 39.9. All right. Oh, let's look at degrees of freedom. 1, 2, 3. So we've got 2 here, and 1, 2, 3, 4, 5. 4 here. 2 times 5 is 8 degrees of freedom. What's our mean? Close to 8. All right. So I'll do a right tail test. Put in 39.911. And yeah, we are extremely off the chart. Yeah. So that's how you can do raw data and summary data. Right here, ChiSquare Test, nice and easy.